This is step 1. Okay. So today we are going to deal with the sulfur dioxide. Okay. So this is one of the other new topic. So now you see sulfur dioxide means SO2. So sulfur atom is the central element which is surrounded by two oxygen double bonds. So here if you find out the oxidation state, the +4 will be the oxidation state of the sulfur dioxide. Okay. So now next we are going to deal with here how to prepare, means preparation methods of sulfur dioxide. Preparation methods of sulfur dioxide. So how many preparation methods now we are going to deal? In that few are laboratory methods and few are industrial methods. Industrial methods, or it can also be called it as commercial methods. Okay. So here the first method is oxidation of sulfur. Oxidation of sulfur. So the sulfur will undergo what? Oxidation, or it can be reacted with oxygen, or it will be what? Burn in the presence of what? Air or oxygen. Okay. So sulfur can be burnt in the presence of air or oxygen. Okay. That is what forms sulfur dioxide. Apart from sulfur dioxide, some tracer amount or little amount of sulfur trioxide such as 6 to 8% sulfur trioxide can also be formed in this particular reaction. So how you see, when sulfur can be what? Treated with oxygen gas, okay, to form sulfur dioxide gas. Sulfur dioxide gas. So this is one of the preparation method for the sulfur dioxide. Now laboratory method. Okay. So how, with the help of laboratory methods, you can prepare the sulfur dioxide. So in this laboratory method, when sodium sulfide is treated, sodium sulfite is treated with aqueous solution of sulfuric acid. Okay. So please listen carefully. In the laboratory method preparation of sulfur dioxide, when sodium sulfide is treated with aqueous sulfuric acid, that is dilute sulfuric acid, to form the sulfur dioxide. To form the sulfur dioxide. Now you see, sodium sulfide means Na of plus, SO3 of minus, SO3 of minus 2. So go for crisscross, it will form Na2SO3. So here you see, when sodium sulfide Na2SO3, that is aqueous, okay, can be treated with dilute H2SO4, that is also in the aqueous form. Clear? So it will form sodium sulfate, that is Na2SO4 plus sulfur dioxide plus water. So sodium sulfate plus sulfur dioxide plus water. So Na2SO4 H2O plus sulfur dioxide. So 3 plus 4 7 oxygen, 4 5 to 4 plus 2 6 plus 1 7. Okay, 2 hydrogen, everything is balanced. Clear? Okay. So now in order to write the ionic equation, okay, ionic equation for the formation of sulfur dioxide, sulfur dioxide, here you see SO3, that is a sulfite ion which is having what? -2 charge, that is aqueous. Okay, can be treated with 2 moles of H plus, 2 moles of H plus. Okay, that is aqueous, in order to form sulfur dioxide plus water molecule. Sulfur dioxide plus water molecule. Clear? So 2 plus 1 3 oxygen, 1 sulfur, 2 hydrogen, everything is balanced. So 2 positive charges, 2 negative charges, means it will become water neutral. So like this I can say that with the help of laboratory method, sodium sulfide can be treated with dilute sulfuric acid to form the sodium sulfate plus sulfur dioxide plus water. So like this the sulfur dioxide can be produced or prepared with the help of laboratory method. Now in this second method is, in the laboratory you can prepare the sulfur dioxide, and this confirmation test also you will do in your practicals also. Okay. So what is that confirmation test? When copper metal is treated with concentrated sulfuric acid. Okay. So with copper metal, with copper metal. So when copper metal is treated with, see here, when copper is treated with concentrated sulfuric acid, so it will form copper sulfate CuSO4 plus sulfur dioxide plus water molecule. So this was the second method for the preparation of a sulfur dioxide. Clear? So I am taking 2 moles of H2SO4. So 4 2s are 8 oxygen. 4 plus 2 6 plus 2 8 oxygen. So 2 2s are 4 hydrogen. Everything is balanced. So what it indicates? Copper means copper turnings. So when copper turnings is treated with concentrated sulfuric acid, it will form copper sulfate plus sulfur dioxide plus a water molecule. Is it clear? So like this, the sulfur dioxide can be prepared with the help of copper turnings. And these two are laboratory methods only. Okay. Now industrial methods. Now third here, laboratory industrial methods. Okay. So how the sulfur dioxide can be prepared with the help of industrial method. So here in the industrial method, you see the sulfide ores such as iron pyrites and iron sulfide, that is also called as zinc blende. Means the sulfide ores can undergo what? Oxidation. To form their respective sulfur dioxide as the byproduct. The main product is sulfide ores, that is oxide ores. Is it clear? So with the help of industrial method, what I am saying, any sulfide ores such as iron pyrites or zinc blende will undergo oxidation or treated with O2 in order to form the sulfur dioxide as the byproduct. Now here you see. So first reaction is from iron pyrites. So what is iron pyrites? Now see, Fe of S2 is treated with oxygen gas. Okay, oxygen gas. So now here you see it will form Fe2O3, that is ferric oxide, plus sulfur dioxide. So here I am taking 2 moles of Fe2O3. So 4 moles of FeS2. So 4 2s are 8 sulfur. So here 8 moles of sulfur dioxide. Okay. See. So 11 moles of O2. Why means 2 3s are 6, 8 2s are 16. 16 plus 6 means 22 oxygen atoms are present. So iron pyrites will undergo oxidation to form ferric oxide as well as sulfur dioxide. Now one more, that is what the zinc blende. So how the reaction will take place with respect to zinc blende? So ZnS zinc blende can be treated with oxygen. So it will form zinc oxide plus sulfur dioxide. Okay. So here I am taking 2 moles of zinc oxide. So 2 plus 2 4 oxygen. So 2 moles of O2. Clear? So here 2 moles of ZnS. So 2 zinc oxide, 4 oxygen. Everything is balanced. So like this the reaction can be easily participate in order to form the sulfur dioxide. So these two methods comes under the industrial methods. So like this the sulfur dioxide can be obtained with the help of these methods. Okay, so these are the different methods we are using in order to form the sulfur dioxide. Okay, I hope the concept is clear for everyone. Is it clear? Physical properties. So the next topic is physical properties of sulfur dioxide. Okay, so in the physical properties of the sulfur dioxide, you see, first one, it is a colorless, toxic gas. toxic gas. It is having pungent and suffocating odor. Okay, so the first physical property of the sulfur dioxide is it is a colorless and toxic gas. Okay, it is highly toxic gas and it is also having the pungent and suffocating odor. And second one is it is heavier than air. It is heavier than air. It is heavier than air. Means the weight of the sulfur dioxide will be what? More than the air. Okay, and the third one is it is soluble in water at 0 degrees C. It is soluble in water at 0 degrees C. Okay, and it is solidified or liquefied at a particular temperature. It can be liquefied. At room temperature. Of atmospheric pressure. How much? 2 atmospheric pressure. Okay, and it can be easily liquefied at a room temperature of 2 atmospheric pressure. And the next point is it can be easily liquefied at 263 Kelvin of temperature and freezes at 197.6 Kelvin. 197.6 Kelvin. So it is a colorless and toxic gas and it is having a pungent as well as suffocating odor. Okay, and it is heavier than the air and it is soluble in water at 0 degrees C. Okay, so here the 8 volumes of the water, 1 volume of the gas can be dissolved in 8 volumes of the water molecule. Clear or not? So here like this it can be easily soluble or dissolves in the water. Okay, so it can be liquefied at the room temperature of 2 atmospheric pressure. So it can be liquefied at 263 Kelvin and freezes at 197.6 Kelvin. So these are the few physical properties of the sulfur dioxide. Now next is the very important, that is chemical properties. Of sulfur dioxide. So in the chemical properties of the sulfur dioxide, the first one is acidic character. Now, how to explain the acidic character of the sulfur dioxide? And one thing, remember that sulfur dioxide means nothing but a non-metallic oxide. So whenever a non-metallic oxide is dissolved in water, the solution will become acidic. So how to check if the solution is becoming acidic or not? The litmus paper is turns from blue litmus to red litmus. Blue litmus paper to red litmus paper, it will undergo change. So this clearly indicates that when sulfur dioxide is dissolves in water, sulfur dioxide gas when dissolves in water, the solution will become acidic. That is H2SO3. H2SO3, that is known as sulfurous acid. So due to the formation of sulfurous acid, I can say that it is having the acidic nature or acidic property. So what is acidic character? When non-metallic oxides are always what? Acidic oxide. When they dissolve in water, they form acid solution. And you can check with the help of blue litmus paper, which will turn into the red litmus. So this clearly indicates that it is an acid. It is an acid. Means sulfur dioxide is having acidic property or acidic character. So I can say that sulfurous acid. Okay, sulfurous acid is an anhydride. क्या बोलूं मैं? Anhydride of sulfur dioxide. Means when sulfur dioxide is dissolved in water, you will get H2SO3. So H2SO3 can also be known as anhydride of sulfur dioxide. Sulfurous acid can be called it as anhydride of sulfur dioxide. Now, again based on what this acidic nature, next I can also be explain that sulfur dioxide is having acidic nature when it is reacted with sodium sulfide. Is it clear? Okay, so now, so it can be treated with bases such as sodium sulfide, so as well as sodium hydrogen sulfide, and it can also be treated with lime. What is lime? Calcium hydroxide. In the similar manner, it can also be treated with any bases such as sodium hydroxide or sodium carbonate. Okay, so like this. Now I am going to explain one of the property here. Now you see, when sulfur dioxide can be treated with lime. What is lime? Calcium hydroxide. Calcium hydroxide can be treated with sulfur dioxide. So what happens here? Now you see, calcium sulfide means CaSO3 taken twice. Why? Calcium is having a +2 charge, SO3 is having a -2 charge. So like this calcium sulfide. So here CaSO3 not taken twice. Okay. So calcium sulfide plus water molecule is formed. Now CaSO3 plus water. Clear? Now this is called as, means milkiness can be observed. White milkiness can be appeared in the test tube. So this milkiness of the calcium sulfate can be easily disappeared when excess amount of sulfur dioxide can be treated. So excess amount in the sense, here you see, when calcium sulfide is treated with sulfur dioxide plus water molecule in the next step. So what happened here? Calcium hydrogen sulfide HSO3 minus and calcium of +2. So HSO3 minus of taken twice. Okay, calcium hydrogen sulfide. Now here you see 3 2s are 6 oxygen atoms are there. 3 4 5 6. Correct. So 2 sulfur atoms. Okay, 2 sulfur atoms and 2 hydrogen atom. Everything is balanced. So the white milkiness of the calcium sulfide is disappeared. White milkiness of the calcium sulfide is disappear. So this clearly indicates that sulfur dioxide is having the acidic nature. That's why it can be treated with bases. It can be treated with bases in order to undergo neutralization process to form the calcium sulfide plus water. Here also calcium sulfide is further treated with sulfur dioxide water to form the calcium bisulfide. That is, white milkiness is disappear, and this is one of the confirmation test that the sulfur dioxide is having acidic character or acidic nature. So thus I hope the concept is clear for everyone. Okay. Now see again based on the first equation I have given that it can treated with bases such as sodium hydroxide as well as calcium hydroxide. Now next is when sodium hydroxide can be treated with sulfur dioxide. It will form sodium sulfide, that is Na2SO3. Why? Sodium is having a positive charge, sulfide is SO3 of -2. So go for crisscross, Na2SO3. So 2 moles of sodium hydroxide I am taking. Clear or not? So 2 oxygen plus 2, 4 oxygen. So water molecule is removed. Please listen carefully. Sodium hydroxide is nothing but what? Base. Sulfur dioxide is nothing but what? Acidic nature. So acid as well as base is reacting with each other, means sodium sulfide, which is nothing but a salt. Which is nothing but a salt. So salt plus water means this step is called as what? A neutralization reaction or not? Definitely a neutralization reaction. Clear? Now, if further excess amount of sulfur dioxide is treated, see, sodium sulfite plus sulfur dioxide plus water, then it will form sodium hydrogen sulfide, NaHSO3. Why sodium is plus, HSO3 is minus, that is called as sodium hydrogen sulfide. So finally you will get 2 moles of NaHSO3. See, 2 3s are 6 oxygen, 3 plus 2 plus 1, 6. 2 hydrogen, 2 sodium, everything is balanced. So this reactions clearly indicates that. So the reaction with water, and the reaction with bases such as what? Sodium hydroxide and calcium hydroxide clearly indicates that sulfur dioxide is having what? Acidic nature. Acidic nature. Is it clear? Is it clear? Okay. Now, the next property of the sulfur dioxide, that is chemical property of the sulfur dioxide, is combustibility. So sulfur dioxide is neither undergo combustion, okay, or it will not react with oxygen, okay. So it will not undergo combustion or it will not supports the combustion, okay, but it will what? Abstract the oxygen. It will attract or abstract the oxygen, okay, from sulfur dioxide with respect to elements such as magnesium as well as what? Carbon. Are you getting my point? So sulfur dioxide is neither undergo combustion nor it supports the combustion, but it can abstract the oxygen, okay, by the elements such as magnesium as well as what? Carbon. Now here you see the two equations. Now I am going to what? Explain. So when magnesium metal is, means it is present in the solid form, can be treated with the sulfur dioxide gas. See what happens here. The magnesium oxide, again solid, okay, magnesium oxide solid plus nascent sulfur can be formed. Nascent sulfur can be formed. So here I am taking 2 moles of Mg, so 2 moles of magnesium oxide. Now one more equation. Carbon, that is what? Present